Hey kids, it's Moore here. We're about to go outside and do some weather measurements. Specifically, we're going to find the relative humidity and the dew point. To do that, we use an instrument called the Sling Psychrometer. It consists of two thermometers, one that is just a regular thermometer that remains dry, and one that has a little cotton piece of cloth on there. We call this one the wet bulb because we're going to get this little sock thing here wet right now. All right, that should do it. So we got the wet bulb wet, the dry bulb remains dry. Now let's go outside and collect some weather data. Sling this thing around. Watch out for your neighbors. Whip it around, and what's happening here is the wet bulb is evaporating. The water off the wet bulb is evaporating, which should cool it down. So you know, like how when you sweat and the wind blows across you, it cools you down a little bit. Same deal here. The wet bulb should be cooler than the dry bulb, and we use those two temperatures to figure out the relative humidity and the dew point. And as you can obviously see, we have a very foggy day up here at Johnson City High School, so this should be kind of interesting, kind of cool to see how this turns out. As I stand out here, I can actually feel little water droplets kind of pelting me in the face. It kind of feels nice. So that should be about long enough. So let's take this thing and we'll try to read those off so you can see. Hello Earth Science friends, we're here to show you how to find the dew point and relative humidity of an air mass. So the first thing you will need is a reference table. Page 12 has got those two charts on it that we'll need. And the second thing we'll need are two temperatures. We'll need what's called the dry bulb temp, and we'll need the difference between the wet bulb and the dry bulb temp. So just to refresh your memories or teach you for the first time, this is a Sling Psychrometer, and it's got a dry bulb and it's got a wet bulb. The wet bulb has a little cotton sock on it that we get wet, and then we sling it around really fast and we can get the dry bulb temp and the wet bulb temp. So once we have those, we do some quick little math and use our chart and we're good. So we just went outside and we found the dry bulb temp to be 10 degrees Celsius, and our wet bulb was also 10 degrees Celsius. And just for fun, this was a really fun one because it was very foggy out when we got these two temperatures, so that's kind of interesting for us. Okay, so the first thing we do is we find the dry bulb temp down to 10 degrees, and then we need the difference between the wet bulb and the dry bulb. So 10 minus 10, let's see here, 10 degrees minus 10 degrees. All right, that's going to be 0 degrees Celsius. So we take this number and use our chart to find our dew point. So there's dry bulb temp is 10. The difference between the wet bulb and the dry bulb is 0. So we just follow those down, where they both intersect, we're at 10 degrees. So for this problem, our dew point is equal to 10 degrees Celsius. All right, so the dew point again is the temperature at which dew will form, at which condensation will form. It basically is at which water droplets will form. So that's pretty neat. All right, for the relative humidity, it's the exact same process. It's just going to tell us relative humidity. And again, relative humidity is the percent that the air is actually saturated. So if it was 100%, the air would be totally saturated. If it was 0% relative humidity, the air would be super dry, no humidity in it whatsoever. So let's figure this one out. So again, we need the dry bulb temp, and we need that difference between the wet bulb and the dry bulb. And again, we already calculated those. So our dry bulb temp was 10. Our difference between the wet bulb and the dry bulb was 0. So wherever those meet, 100%. So for the air mass, for this particular air mass, the relative humidity was equal to 100%. That means the air was totally saturated. And when I went outside and collected this data, it literally was totally saturated. I could feel those little water droplets kind of hitting me in the face. So very foggy day, 100% relative humidity, air was totally saturated. Very cool. Enough said. See you later.